Good afternoon, everyone. I'm not sure if I can compete with a video, but I'm Charles Sutton. I manage Kinetica in Europe. Just try and get these slides up. Cool. So I'm going to introduce you to the fastest distributed in-memory database accelerated by GPUs, and ultimately take you through why we believe there is a massive convergence between BI and AI. So, cool. So first of all, I want to take you through the evolution of data processing. So in the 90s and early 2000s, you very much had the relational data warehouse. So you had your Oracles, your Teradatas. These were basically high-performance machines where customers or enterprise customers invested a huge amount of money on consultants to build data warehouses within their organization. And they were probably analyzing about 3% of their data, and that was very much focused on structured data. In the early 2000s, the web property companies, so your Yahoos, your Googles, your Facebooks, they got slightly annoyed writing a huge check to Oracle every week when they needed to increase their data processing capacity. So they developed a platform called Hadoop. Very much designed and developed for managing huge amounts of distributed storage across multiple machines. I actually worked for Cloudera, so I was one of their first resource in Europe, and I implemented big data solutions across Europe at Cloudera. A fantastic platform for storing data, but it was very much designed for batch processing, and it wasn't designed for your real-time user cases that you're seeing today in business. What happened was in-memory became cheaper, and a lot of people then decided to invest in in-memory solutions such as HANA, MemSQL, and NoSQL solutions. These are fantastic solutions, but again, they struggle to ingest data in real time and serve up that data. When those cardinality or those data sets became huge, it was very difficult for them to manage that and hit any SLAs. And the reason for that is the CPU became the bottleneck. So at-scale processing now became the bottleneck. Cut to the chase to now, we believe GPU acceleration is the future of data processing. The reason for this is GPUs are designed around thousands of small cores, and so they very much can process data in parallel. So a GPU these days has 4,000 to 5,000 cores. A CPU has about 32 or maximum 64 cores per device. And basically a GPU processes data in parallel, so they can action all these actions. So they can process and scan an entire data set and do brute force compute across an entire data set. By the way, we're not the only ones saying this. If you look now, we work very closely with NVIDIA, who obviously created the GPU. And you have everyone from Google Cloud, AWS, Azure. They are all releasing their GPU environments or upgrading their, and they are absolutely hugely investing in GPUs at this present moment to really offer GPU as a service. So it's not just us, and actually you can even look at NVIDIA's share price as well. It's tripled this year. So GPUs definitely are the future, we believe, in data warehousing and data processing. So who are Kinetica, and why am I in front of you? Sorry, just go one more. So who are Kinetica? So Kinetica actually was founded in 2009. We were founded in the US Army, so at that time, the NSA, which has probably got one of the largest databases in the world, really needed to create a platform to identify people of interest or terrorist threats in North America. At this time, around 2009, they already had thousands of nodes of Hadoop, NoSQL platforms, and huge investments in Oracle as well. The challenge they had was it was taking them, at best, they could serve up data in a 90-minute window. These guys needed to ingest billions of rows of data per minute or per hour and serve that data up as in next to real time. So they challenged their internal organization to come up with a better platform. And our founder, Nima, who's our CTO, he had some experiences of GPUs in the FinServ industry. So he built a GPU accelerated database from the ground up. And this went into production in 2012 within the US Army. We also have a patent for it as well. So it went into production in the US Army to identify and serve out that data so they can understand terrorist threats in real time. But also we won the High Performance Computing Award for this deployment in 2014. We were called GPU-DB at the time. We actually changed the name very recently to Kinetica. The reason being is most people started calling us Goopy-Doo, which doesn't really bode well. So we decided we had to give ourselves a better name. But we actually we became commercially available in 2014, but we actually had no sales or operations team at all. These were companies approaching us because they were looking for solutions to better understand their real-time analytics requirements. And one of those customers was the US Postal Services. So US Postal Service is probably the biggest logistics company in the world. They deliver more post than DHL and UPS deliver in a year. They deliver in a day. So these guys seriously have a lot of post to deliver. They have around 250,000 vehicles on the road in North America, and they basically use Kinetica to track in real time the location of their vehicles. So they can reroute their vehicles in real time due to peaks in demand and due to weather and traffic constraints. They believe they save themselves around 7 billion gallons of fuel a year by using Kinetica. It's actually used by about 20,000 people inside the US Postal Service as well, so it's kind of absolutely enterprise ready as a platform. But not only that is, they can now actually almost down to the minute track where people's post is. So it's transformational for these guys. They can actually now, if their tools allow them to, they can pretty much communicate to their customers next to real time when they're going to get delivered their post. So it's transformational for their business. We had other customers approach us as well. We have a partner called IronNet who do cybersecurity and look for anomaly detections, and they work with a lot of the financial services companies using our platform in their business. We also have the largest utility company in the US, Pacific Gas and Electric, again, who use us to really understand peaks and troughs in demand for their electricity supplies. So I'm conscious of time. So some of the use cases we're seeing. So we're working across multiple verticals at this present moment. So we're working with the largest retailer in the world. They actually purchased over 60 devices, Minsky devices, to use Kinetica on very recently, just to show you the scale of, and what they needed to do was they really needed to understand their POS information, so their point of sale information and their inventory information, and track in real time out of stock situations. So for this particular retailer, it cost them billions of dollars a year in out of stock situations because they could never in real time understand their inventory demand and making sure the inventory was in the right place. So they very much use Kinetica now to really match their inventory and their sales information. This was the first time they could achieve that. They have multiple other user cases they're using with us now, which is really about understanding their customer and giving the best customer service. But we're seeing a huge amount of momentum in retail. We're also seeing a lot of momentum in financial services. The reason being is actually in the risk space, low latency is a critical requirement, but they've actually already invested a lot in GPUs within the risk space in financial services, so it's just a natural extension for these guys. We're also working in the last speaker, we actually are working in that space with a number of customers in the US now, so love to talk to you afterwards, but yeah, in the genome modeling space, we're accelerating that process, and we're also working with quite a lot of the car companies as well. So in the connected car or the connected city world, where they need to streaming huge amounts of data and serve that data up in real time, then it's a very strong platform. I've got this working now. So just performance benchmarks. So because, as I said, we have 4,000, 5,000 cores per GPU, the performance we can gain is magnitudes higher over any other in-memory database. So As you can see here, so we're kind of from the 100% performance improvement to the 500 to almost 1,000% performance improvement you will see over your more traditional in-memory database platforms. Can we just go to, yep, cool. So one of the retailer I mentioned actually benchmarked us against SAP HANA, which was their incumbent solution. And they obviously did their most complex queries on our platform. And you can see here, we're for a group by join or select some of the time and performance improvements they gained with Kinetica. I would add, so we were benchmarked with far less kit than SAP HANA was. We could ingest 1.2 billion rows of data in a minute. It took them over an hour to do 1 billion rows on SAP HANA, and we had a far less server estate or capacity. So it's not just performance gains, it's also you're absolutely reducing your hardware footprint as well. So one thing that's interesting is we scale linearly across, so we can scale predictably, so we can scale to tens to hundreds of terabytes, conscious of time. So, but as I said, we reduced the footprint substantially as well. So in the US Army, I think we reduced the footprint of their hardware environment by over 40 times. And the US Postal Service, it was around over 10-fold that they reduced their hardware footprint. So not only do we get performance gains, we get reduction in footprint and reduction in power, reduction in cooling. So there's huge gains to be had there. What I forgot to mention as well, just quickly, if I went back to here, was we actually benchmarked this with NVLink as well when it came out at the end. And we actually got a 3 to 10x performance improvement in this customer by taking advantage of the NVLink capacity of power. And that is the reason why we're so focused on partnering with Power today. That is just, we think it's a huge, huge, huge win for Kinetica. So the interesting thing about it is we plug into your existing architecture, but you don't need to do any tuning or indexing or that you would need to do with a traditional CPU platform. So we also have built NLP, so we built Lucene under the bonnet in our platform. And we plug into the more traditional business intelligence applications. We're working with Tableau at the moment. They kind of did make me laugh when I met them the other day because they used to be called TabSlow, and so they quite like the fact that we have a database that can give them the speed they require, but we're also working with a lot of the open source frameworks as well. And we actually have a very powerful geospatial UI purely because of our GPU heritage. We're very strong at rendering data both geospatially and temporally. So where do we fit in? So we fit in as that in-memory layer. So we're really good at streaming analytics. So we very much fit into most customers' reference architecture. We're SQL 92 compliant. But we work with the data lake, so we really try and gain or drive value out of the data lake already in play. So the Kinetica architecture very much takes advantage of the open source integration frameworks, whether they're Kafka, Spark, NiFi. We take advantage of those, and we also use the more traditional integration platforms as well. We have standard ODBC and JDBC connectors, but we have a RESTful endpoint as well. And finally, just conscious, one thing we're seeing now is a lot of customers have already investing in using GPUs, and they are using tools like TensorFlow, Caffe, Torch as their solutions for AI. What they're actually seeing is because we also take advantage of the CUDA libraries, we can actually define UDFs with our platform. So when a process is being run on Kinetica, they can absolutely kick off the process, go and call that CUDA library and run that UDF and bring that result back in near real time or real time, which is transformational. They don't have to move the data. So we believe there is a massive convergence now. We're seeing more and more BI being automated by AI workloads, but also this is where we believe that there is a massive convergence in BI and AI. Thank you for your time.